This is going to be a very brief, you'll notice there's only 4 slides, very brief introduction into a slope or direction field. And I'm actually going to help you guys, or I'm actually going to direct you at some point after we do this together and try some activities in class. I'm actually going to direct you to the AP Classroom, has some videos that you can watch that I actually watched as well before doing this to help you kind of understand how these questions might look on the AP exam in May. So again, this is just a very, very basic introduction into what a direction field is and how we can use it to help us determine solutions for differential equations. So I'm going to look at this differential equation right here. All right, and we're going to create one. All right, I'm going to show you how to create one on Desmos, but I'll also put the one from the book on the screen. And then we're going to look at any of the solutions or equilibrium solutions to this, essentially, which just makes the right-hand side become 0. And then we're going to classify those solutions based on what we see in the field. So let's do a little bit of algebra here and just set y minus 3 squared equal to 0 and y squared plus y minus 2 equals 0. So this one's pretty straightforward. Positive 3 is going to make that 0. This was where I'm going to factor. So y plus 2 times y minus 1. So my two solutions here are going to be y equals negative 2 and positive 1. So when you look at the direction field, which is right here, I know there's a lot going on, but if you just focus for a second on those values, which were negative 2, positive 1, and then positive 3, right? You can see that the all of the arrows, right, if I take them away, all of the arrows are going to be horizontal lines because that means the slope of the differential equation is going to be 0. So essentially how they build this is they just plug in values into y, and a lot of these have x as well. This one only has y. But essentially, if you just plug in, like if say you do, let's just try one here. I'll do ordered pair of 5, 4, okay? So if I plug in x is 5, don't have an x, so I don't have to worry about that. So I plug in 4 for y, I get 4 minus 3 is 1, which is 1 squared. Let me do that right here. So 4 minus 3 squared, and then 4 squared plus 4 minus 2, so that's 1 times 16 plus 4 is 20. 20 minus 2 is 18. So you get 18. So when I go to this ordered pair of 5, 4, I should see a tiny little line. In this case, they do arrows. But a tiny little line, like a tick mark, has a slope of 18. So I go to 5, 4. Let's see. 1, 2, 3, 4, 5. It's not on here, so that's okay. 1, 2, 3, 4. So this slope right here would be like 18. All right, something like that. So that's essentially how they're figuring all this out, is they're just doing that. And if you go to Desmos, you can actually build one by typing it in. So if I type in y minus 3 all that squared times y squared plus y minus 2, it will give me the same thing. So we have y minus 3 squared, and then y squared plus 2y minus 2. Make sure I confirm that. Plus y. There we go. Okay, so if we look at, zoom in a little bit. All right, you can see our equilibrium solutions at 3 and at 1 and at negative 2, like we already found. All right, what was that point? 5, 4. So here's 5 and here's 4. So this right here, this purple line, is a slope of 18. So it almost looks vertical, but it's not, right? It's very, very steep, but it's a slope of 18. So anyway, you just do that a ton, and that's how you build it. Now, as I said, I'm going to show you guys, one thing that's kind of cool here is you can move this point around. I thought you could, maybe not. Where's my movable point? Anyway, I thought you can move it around. But what's cool is you can actually, when you do the questions on AP Classroom, you're going to see that you'll see the different ways that they ask you about it. Okay, so let's just finish this problem then. So the last part was asking, classify these solutions as stable, unstable, or semi-stable. So here's how we're going to do that, okay? I'll just use these two slides here. All right, so the first solution, if I start from bottom to top, is going to be -2. So equilibrium solution y, that's not solution, solution y equals -2. All right, so when I look at the points that are right below it and above it, you'll notice that all of my arrows or lines are pointing towards the 2, right? So these are pointing at it, and these are also pointing at it. So that means this is going to be a stable solution. So this one is stable, all right, because both any ordered pair that's just above it or just below it, the slope of those tangent lines is actually pointing right at it. So that's why we call it a stable equilibrium solution. Let's do the next one. All right, so this one is y equals +1. Confirm, yes. All right, so let's see what's happening at +1. All right, so at +1, just above it, these arrows are pointing away from it, and just below it, they're also pointing away from it. So since they're pointing in opposite directions from that +1, we call this an unstable equilibrium solution. And the last one, which is +3. All right, if I look here, solutions that are above it are pointing away from it, but solutions below it are pointing towards it. So since like on one side you got them pointing away from it, the tangent line slopes are pointing away from it, and the other side they are pointing towards it, we call this semi-stable. All right, again, don't stress so much about this. This is just very brief introduction into a slope field. We'll do an activity on Desmos. I'll do a little card sort activity to practice, and then, like I said, I'll direct you to those videos on AP Classroom, which will help you kind of solidify your understanding on this.